So we've got some more vocabulary for types of angles. Now these types of angles are always be formed when you have two lines with a transversal. Usually those two lines will be parallel. So here's two lines, P and Q, with a transversal. Transversal just means it's a line that goes through the two of them. So T would be our transversal. So when you have that, you have a lot of different angle pairs that we give special names to. First, we have corresponding angles, which are on the same side of the transversal and on the same side of the intersecting lines. So they're corresponding. They're in corresponding positions at the two intersections. So if you look at, here's one intersection, different color. And here's the other intersection. There's two intersections and they're in corresponding positions. So that would be like angle 1 and angle 5. There's three other corresponding angle pairs though. You could also take angle 2, that's corresponding with angle 6. Angle 3 is corresponding with angle 7. In the same spot, like the bottom right, bottom right. And last, we have angle 4 is corresponding with angle 8, bottom left and bottom left. They are also corresponding angles. So they seem to be in the same position, the same spot, corresponding positions at the intersections. Next, we'll look at same side interior. So interior means, same side means that they're on the same side of the transversal, and interior means between or inside the other two lines. So if these are our two lines, usually, like I said, they're parallel, has to be inside, so in the interior of those two. Angles 3, 4, 5, and 6 are the only angles in the interior. And then they have to be same side. So 3 and 6 are on the same side. They're both on the right side. And 4 and 5 are both on the same side. They're on the left side. So angle 3 and 6 and angle 4 and 5, they're both same side interior. Then there's alternate interior, so still interior, still inside the two lines. But this time they're on alternate sides. So that's like angle 3 and 5, because they have to hop over the line, they have to hop over the transversal, one on the left, one on the right. Or you could also pair up 4 and 6. Those are also alternate interior. And then alternate exterior. Interior means inside, exterior means outside. So the exterior angles are 1 and 2 because they're not in between those two lines. 1 and 2 are outside, 7 and 8 are also outside. Alternate means opposite sides. So 1 and 7, they're on alternate sides. One's on the left, one's on the right. And then 2 and 8, one's on the left, one's on the right. So with all these angle pairs, there are some postulates which tell us what the angles are. So first, same side interior angles. If the lines are parallel, then the same side interior angles are supplementary. And again, supplementary means they add to 180. So we can first identify which angles are same side interior. That's interior means between those two parallel lines. And then same side, that would be 3 and 6. And also 4 and 5. That's another pair. And the postulate we were just talking about says that they are supplementary. So we could write that they're supplementary. Or you could write that they are, they add to 180. So you can make like an equation of that. Angle 3 plus the measure of angle 6 equals 180. And we can also say the measure of angle 4 plus the measure of angle 5 equals 180. So if angle 4 is 70 degrees, use some substitution, substitute 70 degrees in there, plus the measure of angle 5 equals 180. And then we can find the measure of angle 5 by subtracting. We get the measure of angle 5 equals, subtract 70, you get 110 degrees. So a very similar question for angle 3 and 6. If you know that angle 6 is 61, you substitute that in, so you get measure of angle 3 plus 61 degrees equals 180 degrees. And then you subtract. You get 119 degrees. So now we'll talk about alternate interior angles. And if the lines are parallel, then the alternate interior angles have the same measure. Or you could say that they are congruent. Same measure, congruent, same thing. They're equal. The measures are equal. So we're going to go through a little bit of a proof. When you're proving something, you can use definitions, properties, postulates, and theorems that you already know. So all of your knowledge, basically, you can use. But those would be the reasons: the definitions, the properties, the postulates, and theorems. So since we know that the lines are parallel, that's what we're going to start with. Line P is parallel to line Q. P is parallel to Q. And we're going to prove that angle 3 and angle 5 are equal in measure, which is what the theorem just said. They have the same measure. Alternate interior angles are equal. So here's a list of a bunch of different postulates that we know already and properties. So you always start with what you are given. P is parallel to Q because it is given. Now, angle 3 and angle 6 are supplementary. So here's angle 3, here's angle 6. Those are on the same side of the transversal, and they are inside the parallel lines, which means they are same side interior. Since they're same side interior, that means that they are supplementary. That was the postulate we just had on the previous slide. So since they are supplementary, that means that they add to 180. That's the definition of supplementary. You can use definitions. Now, angle 5 and 6 are a linear pair. 5 and 6, yep, we can see by looking at that they are a linear pair. They make a straight line. They're side by side. Actually, I would say that's more of the definition of a linear pair, but linear pair theorem works there too. And 5 and 6 are supplementary. I'm going to move linear pair theorem right here. I'm going to write definition of linear pair here. The linear pair theorem says that since it's linear pair, they are supplementary. And then since they are supplementary, that's the definition of supplementary. They add to 180. So we just said that angle 5 and angle 6 add to 180. Here's angle 5 and angle 6. And earlier in step 3, we said that angle 3 and angle 6 add to 180. And here we have angle 3 and angle 6. We can combine those. Since they both add to 180, they both equal 180, that means they equal each other. That is called substitution. And you don't always have to write substitution property of equality. You could just write substitution. Write all of those words. So we have this equation here, and measure of angle 6 is on both sides. When you have an equation and the same thing is on both sides, you could subtract it away, and we'd be left with angle 3 and angle 5. When you subtract away the measure of angle 6 from both sides. So if we subtract that away, that's called the subtraction property. Or you could just write, subtraction or subtraction property if you don't want to write all the words. So we just showed that they are equal, and by looking at them, we can see that they are alternate interior, so we just proved the theorem, which is what we were supposed to go through right there.